Hello everyone, my name is Songge and I'm come from Harbin Institute of Technology. I'm very pleased to be here to join this committee. The topic of my presentation is on the performance of diversified hybrid carrier system based on the extended weighted fractional Fourier transform, which is abbreviated as WFRFT. Our research group is devoted to studying the application of fraction domain in the field of communication security, and EWFRFT is an extension of that. As is shown in the content, the main parts of our research are about extended hybrid carrier system and its applications in security. My presentation will include these four parts. In recent years, weighted fractional Fourier transform as a signal processing method in the transform domain has been gradually applied in wireless communication systems and has shown a broad research prospect in the field of physical LoRa security. In fact, due to its unique four-components superposition structure and beneficial changes to the signal characteristics, traditional fractional domain signals, just like HC and GHC, can already provide considerable performance improvement for SC or MC systems. And a series of secure transmission schemes have been proposed to cope with the rapid development of target interception means by eavesdroppers. However, they still have some shortcomings, as the security capability of WFRFT is constrained by the transform parameters, and the transformation degree of freedom is limited. The signal is at risk of being cracked. With the extensive research of WFRFT theory, the eavesdroppers gradually master the same prior knowledge of the fraction domain as the partner, which makes the transformation in the form of a single parameter unable to effectively guarantee the security of the system, especially facing eavesdroppers with strong computing capacity. To cope with the defects of the existing hybrid carrier system, on the one hand, researchers try to combine WFRFT with antenna array and other physical LoRa security technologies to improve the overall security performance of the system. On the other hand, there are also some studies on the extension of the transformation form. GWFRFT shows the possibility of parameter extension through the construction of the coefficient parameter vectors, which has more abundant multi-components energy distribution schemes compared with WFRFT. GWFRFT can improve the demotion partly due to the relaxation of the boundary conditions, but its research mainly focuses on combating channel fading through parameter design. The potential safety hazards of the existing hybrid carrier system has not been effectively remedied. Therefore, it is of great research value that extending the WFRFT form to construct diversified anti-intercepted signal forms. In this paper, an extended weighted fractional Fourier transform based extended hybrid carrier system is proposed. By extending the basic operator and constructing the weighting coefficient vector, the signal energy can be further distributed to more components, which greatly increased the diversity of the transformation and the difficulty of intercepting. Figure 1 shows the transmitter framework of the WFRFT scheme. In particular, the transform parameters can be dynamically generated according to the actual communication needs to ensure the anti-interception performance. Besides, WFRFT is compatible with the existing communication system and various physical law security schemes. The proposed scheme has good universality in the field of anti-interception. Then the basic characteristics of the QPSK signal after WFRFT are simulated. It can be seen that WFRFT signals do not require additional time frequency resources or hardware conditions, which have good compatibility with the current communication system. Meanwhile, it also has good Gaussian-like distribution derived from the change of signal characteristics by WFRFT, which is beneficial to the anti-detection. The simulation results show that there are rich parameters combination of WFRFT, which can achieve that kurtosis is approximately zero, regardless of the modulation mode. That is different from the simple change of WFRFT signal setters with the transform parameter alpha. Due to the extension of parameter dimensions, the proposed scheme has design flexibility and can achieve diversified Gaussian-like distribution, which has advantages in signal hiding and anti-recognition, as well as good universality. The proposed transformation can make up for the defects of the existing hybrid carrier system and effectively improve the physical law security of the communication system. On this basis, to decrease the cost of cooperative communication, we give a fast implementation scheme just like simplifying the calculation of DFT by FFT, which can ensure the feasibility of the proposed scheme. The expression of the algorithm is given, and the figure shows a basic iterative structure, schematic diagram of the simplified implementation progress, which can be combined step by step to realize the WFRFT. It is worth noticing that due to the unitarity of the interpretation function, the WFRFT simplified algorithm can realize the undistorted recovery of the signal as long as the reverse transformation is carried out step by step in the opposite order to the forward one. Thus, there are diversified iteration methods. In addition, the iterative function is not unique. Due to the diversity of physical operators, the proposed scheme has strong design flexibility, which is beneficial to resist the eavesdropping of unauthorized receivers. In particular application, it should be reasonably selected according to the system complexity limit and the security requirements to ensure the overall performance of the system. We first verified the feasibility of the scheme. As can be seen from the simulation results, The undistorted recovery of the WFRFT modulated signal is realized, which proves the unitarity of WFRFT and the equivalence of the fast algorithm with the original transform, thus granting the feasibility of the proposed scheme in anti-interception. Next, we describe the structure of the receiver as shown in the figure. The inverse transform module can also be implemented in a simplified multi-level iterative process for the partners, since all parameters are shared. The original signal can be recovered without reduction of the equivalence signal to noise ratio by performing the corresponding inverse transformation, which ensures the reliability of the partners' communication, while for the eavesdroppers to reassemble the original signal from the energy-despaired signal. It should accurately judge the signal processing means adopted by the transmitter and select the correct inverse transformation operator to realize the signal reconstruction. When the operator cannot be exactly chosen, the eavesdropper will hardly obtain any useful information in high probability. In fact, due to the extension of the transformation form, WFRFT has the extensibility and the design flexibility of the physical operator, which will create obstacles for detecting the signal and ensure the physical law security of the system. On this basis, the eavesdroppers not only need to master the constant implementation process of the WFRFT fast algorithm to realize the inverse transformation of the operated complexity, but also need to determine all transform parameters. Otherwise, it will lead to a decline in receiving performance. We give the beta error rate under different prominence errors as shown in the figure. For the eavesdroppers, the introduction of the EWFRT greatly reduced the equivalence signal-to-noise ratio of the received signal and the reliability of communication. According to the tolerance determined by the analyzed result of sensitive, the eavesdroppers have to scan all transform parameters to intercept the signal. In this way, the computational complexity can be expressed as follows. Compared with that of the eavesdroppers in the WFRFT scheme and the GWFRFT scheme, it can be seen that the EWFRFT scheme greatly reduced the cost of eavesdropping due to the extension of the transformation form, which reduced the possibility of interception through parameter capturing. Thus, it makes up the drawback of the existing WFRFT scheme and ensures anti-interception performance. In the communication synthesis with real-time requirements, especially considering more uncertainty brought out by dynamic changes of parameters jointly, it will inevitably lead to the decline of receiving performance when the eavesdroppers cannot pay such a high computation complexity, which guarantees the confidentiality of communication. The proposed scheme gives a great improvement of secrecy performance at a small cost, obviously. and we analyze the expected secrecy capacity of the system. It can be seen that when the parameters cannot be correctly selected, the expected secrecy capacity shows a steep growth trend with the increase of SNR as well as that of parameters error, indicating that the system has achieved great secrecy performance. Besides, the anti-interception advantages brought by the diversity of WFRFT signal are fully utilized in the proposed scheme. The transform parameters with Hager motion greatly improve the flexibility of the weighted transformation design. On this basis, because of its good compatibility, it is no obstacle to combine the WFRFT scheme with various traditional physical security technologies that can selectively degrade the eavesdropper's channels, which will obtain higher security capacity. Here, WFRFT and related research results are displayed. It is not only get a good performance improvement of anti-interception with a small increase in computation complexity, but also has design flexibility and is worth of further study. In the future, we will continue to work in the field of anti-interception and weighted fractional Fourier transform. That's all. Thanks for your listening.